Welcome, digital pathology trailblazers. Good morning, 6 a.m. from Pennsylvania. Saying hi in the chat. So if you are here, let me know that you're here and where you're tuning in from. And of course, what time is it? Did you actually wake up at 6 a.m. to do this with me? I know some of you do, and I appreciate that very, very much. So let me know where. Okay, I see people. There's always a little bit of a lag before, like, when I go live, and then I'm like, are they coming? Are they coming? You are coming. So let me know if you hear me well. If the mic is working, let me know where you're tuning in from. And it's already February. Can you imagine? 2026, the second month. Coffee ready? Waiting for some of the reactions of you to know that everything is okay with the tech, because regarding the tech, I have a new computer and different new things that hopefully will not give us any trouble today. And my trailblazers are here. Welcome, Monica. Amazing. If audio good, visual good, then let's dive into the papers, into the abstracts that I have for you today. We have a few cool ones, and I am so super happy to start with guidelines for the adoption of digital pathology in clinical pathology units recommended by the Polish Society of Pathologists. And we have guests from Estonia. Amazing. Eastern Europe. So I'm super happy, of course, that Polish Society of Pathologists gives us these guidelines, because I'm from Poland, and I'm looking where the authors are from, and they're from Bydgoszcz, Kraków, Zakopane, Poznań. I went to high school in Poznań, so I know where that is, and I'm, of course, super proud about this being published in Diagnostic Pathology. And I checked, so let's go high level first, because these are guidelines for the adoption of digital pathology in clinical pathology units. This publication comes out of Poland, but it's not specific to Poland. And actually, I went in and I want to show you what's in there, for you to actually, maybe we're going to review it in more detail. So if you would like to go through these guidelines with me at some point, leave me a comment with the word guidelines, because we can just go through them together. But for the purpose of DigiPath Digest, I just want to mention this to you, but I'm going to show you what's in there. Give me 1 second here. So they have advantages and applications of digital pathology. We're familiar with that, but we also have, let me just double check that I'm sharing. Yes. We also have key technical considerations. We have scanner image quality parameters, resolution and color depth, and image compression and data formats in digital pathology. I'm going to go back to this color depth. This is something important in pathology. We had a podcast episode on that, and Monica, who's here in the live stream today listening, she was the guest, and also Tom Kimpe from Barco. They produce screens, medical screens, and they did extension color, so that's important. Then we have digital archiving in digital pathology, and they point out in the abstracts, I'm going to tell you in a second, that there are still requirements for archiving of glass slides, and that's not going to go away. Cloud solutions in digital pathology, image quality control, a big thing that many people are talking about, and we're going to have an abstract on that as well. Monitoring quality for digital slide assessment, and end user computer requirements in digital pathology. technical specification, like everything, right? Maintenance and calibration of scanning devices, system integration and data management in digital pathology, correct assignment of microscope slide specimen to virtual images. Like we all know that, okay, a glass slide can be mislabeled, but hey, what about mislabeling the pair of glass slide and digital image? I did not read about that consideration before. Approval of hardware and software in digital pathology systems, validations, recommended validating procedures. So, long story short, super proud of this publication. Not only because it's from Poland, and I think there is value in like new countries embarking on this journey, describing how they're implementing, because they already have a lot of resources. So not only are they describing what are they going to do in Poland, but also they have access to all the resources of everybody who came before them, and they add additional consideration, additional angles from somebody who's newly implementing. I love that. So highly recommend to go to this one if you are starting your digital pathology journey, if you're starting to implement, and just like the newest publications are going to have the most up-to-date, basically are going to reflect the most up-to-date reality. Let's see if I did not miss anything from the abstract, itself. Yeah, they present a clear and practical framework for the effective implementation of digital pathology in routine anatomic pathology practice. And they define digital pathology as digitization of microscope slides into high-resolution whole slide images. We know that definition, and digital systems are becoming increasingly integrated in pathology laboratories. But they mention here, hey, the physical archiving of microscope slides remains a legal and procedural requirement in many countries, particularly for histological and cytological materials. And they have this publication with recommendation addressing key technical, organizational, and legal aspects of digital pathology implementation, with an emphasis on ensuring consistent quality and minimizing variability in diagnostic outcomes. Very high value in this type of review publications, which are pretty difficult to assemble, because every time you write one of these, there is more and more to consider. But we sure need them, because then somebody else can take them and use them. And we have somebody from, let me show this on the screen, Silver Spring, Maryland. That's 6:08 a.m. So kudos. Thank you so much, Sean, for joining us today. Okay, let's go to the next one. Incorporating AI into imaging for surveillance and diagnosis of liver cancer. I'm thinking like this live stream would not be itself if I didn't have some technical difficulties. So today I have a new PDF annotator, and I have this pen that of course is not working on the screen that I'm supposed to use it. So apologies for me using the mouse and not making straight lines, but I'm going to use it anyway. This publication comes from France. Oh my goodness, it looks ugly. But it's real, guys. At least you know I'm not AI, and I actually like cannot make a straight line with my mouse. I hope it's a little bit entertaining for you. So we have primary liver cancer, hepatocellular carcinoma, or intrahepatic cholangiocarcinoma. They remain a leading cause of cancer mortality worldwide. And I think that for every type of cancer, there is this statement that it is the leading cause of mortality. And one time I had like stats which cancer is the most prevalent, but obviously every type of cancer is a cancer diagnosis that has to be dealt with. But The current surveillance and diagnostic strategies, they rely on, so here we're talking radiology at the moment. And this is contrast enhanced CT and MRI, and they suffer from operator dependence, limited sensitivity, and interpretive variability. We know that every time a person looks at something and a different person looks at this, you have inter-observer variability, whether it's pathology images, radiology images, or whatever you're doing, I guess, that you're trying to assess. So that is a limitation of non-computerized ways of diagnosing, which were the ways of we were diagnosing forever, and we still are. But AI offers this potential across the liver continuum to, with deep learning and different modalities now, foundation models and whatever comes out, the newest thing that keeps outperforming the old thing. The deep learning based models have improved ultrasound detection of small liver tumors, and they are enabling automated triage and reducing workload. On CT and MRI, we in this particular application, they achieved expert level performance for lesion detection, segmentation, and characterization. And the models support standardized interpretation through frameworks such as LI-RADS, and this is liver imaging reporting and data systems. So, sorry, now you see it. And it's so something to highlight here, right? More and more we see this, oh, we are building a model, but we are referencing this framework. We are operating within these diagnostic criteria. So it's not freestyle AI anymore. It's actually AI aligned with the framework that we are using in the diagnostic space, which is a step towards integrating this in the diagnostic workflow whenever the lab or the group or the institution is ready for integrating. You don't have to figure out, okay, how does the AI AI model decision support maybe, or diagnosis align with what we have been doing visually so far. It already does, because that's how it was designed. And here they are referencing this liver image reporting and data system. And, there are different systems, different diagnostic criteria for different cancers. But the highlight here is, yeah, we are aligning with what we already know is working and represents current framework. So, interesting things, the AI algorithms can distinguish between hepatocellular carcinoma and cholangiocarcinoma. They can classify dysplastic nodules and even predict future cancer development from biopsy slides. If I could, I would put a little heart here, because now we're entering pathology space. And so the advances in foundation models and multimodal AI promise to unify radiology, pathology, and molecular data. And we are seeing abstracts about that, right? When there is multimodality, even like little multimodality, just radiology and pathology, or just histology, histopathology, and molecular data. So like just pairing as like labeling one data modality with another data modality that is not text or annotations. But now more modalities will come into the picture. And the more data points we have, the more the better the models are going to be. So for me in the preclinical drug development space, whenever I am a pathologist, toxicologic pathologist, so I evaluate pathology. But there is this approach called weight of evidence approach. So we take all the different available data, and we and that's not different than clinical practice, right? I'm just relating to my own experience. So the weight of evidence, whatever other information we have, be it clinical pathology lab data, IHC, wherever, right? We take it, and this weighs into our interpretation. So here, that's kind of a parallel to the multimodality. Now the AI models can try to, and I'm doing like quotation mark with my fingers, they can interpret the weight of evidence as well. And if you're just joining, let me know. What did we say at the beginning? Who just joined? If you want to go together through the guidelines for adoption of digital pathology from the recent publication by a Polish group that we discussed at the beginning, let me know in the chat. Put the word guidelines. And if you don't, that's okay as well. So, but of course, we have challenges as well. There is no digital pathology without challenges. There's no new technology without challenges. So even though we have the more capabilities with more modalities, we can implement the weight of evidence into AI models, while clinical integration faces major challenges, including data privacy, regulatory approval, cost sustainability, and algorithmic bias. And several of these we already covered in previous DigiPath Digest. For the algorithmic bias, I'm going to refer you to the 7 parts AI in pathology, 7 parts article series. And there is a course that I prepared on this. It's called Pathology AI Makeover. This, you will see a QR code in, for me, it's the left upper corner. Definitely upper, check if left or right for you. But in this Pathology AI Makeover, if you're new to this, if you're just starting pathology and AI exploration, this is a course I prepared that includes all these, all our live streams edited in version audio and video, and more about AI. So if you're new, I highly recommend you can scan the QR code and see what's in this course. But we have a few more papers yet. So yeah, what are the challenges? We said the challenges, and what do we need to overcome these challenges? Well, we need scientific proof. So obviously, prospective multi-center validation studies are essential to confirm clinical benefit and safety. And they highlight also, okay, careful implementation, trustworthy and explainable AI tools. If we have that, we can enable earlier detection and greater diagnostic precision and more equitable liver cancer care. Uh-oh. I'm saying uh-oh because I hear my kids walking upstairs. I hope they keep sleeping. They are not supposed to wake up until 7 a.m. And I told them specifically, if we wake up earlier, don't come in because I have a live stream. I may get off camera if they come in here. So just stay with me. If I disappear for a second, stay with me. Okay, this one is super cool. The next publication, next abstract, from slides to AI ready maps, standardized multi-layer tissue maps as metadata for artificial intelligence in digital pathology. This is so cool, so simple, so innovative. And this is a European publication, group from Graz, Austria, Czech Republic, Brno. We have Germany, Charité, and we have Lisbon, Portugal, which I may be visiting pretty soon. And from the authors, I know Norman Zerbe. I'm looking if I know anybody else. No, but so whole slide images, we know what they are. They are high-resolution digital images created by scanning the entire glass slide, and they are created at the multiple magnification. And they are the cornerstone of digital pathology, right? But they are also being used in neurology, veterinary medicine, shout out to all veterinary pathologists, hematology, microbiology, dermatology, pharmacology, and toxicology. Shout out to toxicologic pathologists. Okay, and I see people wanting the guidelines, specific guideline live stream. We're going to do that then. Okay, maybe next time we can go through them. Mm, Immunology and forensic science. So when we are assembling cohorts for AI training or validation, we would like to know what's inside these cohorts, right? Um, what is the content of those whole slide images? So far it was like opening the image, checking what's there, and then uh, somehow assigning it to your cohorts. There are no standards that currently exist for this metadata. So metadata, wishful thinking, right? We would like to have this information, what's in this tissue in the metadata. Sometimes we have, most of the time we don't have. So we rely on manual inspection, which is not suitable for large collections with millions of objects. Come on. Okay, my highlighting is imperfect. So what this group proposed, a general framework to generate 2D index maps, tissue maps, that describe the morphological content of whole slide images using common syntax and semantics to to achieve interoperability between catalogs. What does that mean? They have an AI model that goes into the slide, checks what's on the slide, and then includes this in the metadata so that when you look for a specific something in the slide, and we're going to say in a second what something, you don't have to open the slide because the AI model already did that and assigned the metadata. So they have 3 layers. They have source, tissue type, and pathological alterations. And each layer assigns whole slide image segments to specific class, providing AI-ready metadata. And this AI-based metadata extraction from whole slide images, they used it to generate tissue maps and integrating them into a whole slide image archive. So it enhances search capabilities within the archives and facilitating the accelerated assembly of high quality, balanced, and more targeted data sets for AI training, validation, and cancer research. Um, so they used TCGA data set and they checked it, basically validated with expert opinions, but the AI goes in, says what it is, what tissue type and pathological alteration. So it doesn't like go and diagnose or gives you a specific diagnosis, but it's going to give you the information about neoplastic, non-neoplastic, and whatever the training there was. And then it extracts it and puts it into metadata. I think it's so efficient. I just like such a low-hanging fruit for the use of AI and empowering everybody who is doing AI research on pathology, right? So let me know your thoughts. Was it going to be helpful for you? If you're a computer scientist working in the space, for sure. Okay, I have a few more. We have 2 more. Okay, PathQC. This is also an interesting one that kind of builds up on the concept that we had in the previous publication and the extraction of information from the slide for metadata. This is for quality control and determining molecular and structural integrity of tissue from histopathological slides. This is San Diego, California, and we are talking about application in biobanking. Quantifying tissue molecular and structural integrity is essential for biobanking, and current assessment methods, especially for molecular, they rely on destructive testing that depletes valuable specimens and rely on manual evaluations. So again, not scalable, right? Whenever we have to do it manually, we cannot scale. And PathQC is a deep learning framework that directly predicts the tissue RNA integrity number, the RIN, and the extent of autolysis from hematocrit and eosin stained whole slide images of normal tissue biopsies. This is in general, something that I see in the biobanking, biomarker development, biomarker workspace, because you often rely on purchased specimen. And me personally, with my own eyes, I have seen specimen that were paid for and didn't contain any of the tissue that was supposed to be there, or it was all autolytic, all necrotic, or like it was useless basically. And you had no way of basically checking it before purchasing, like block. You can look at the block. Very rarely, well, even if they were glass slides assigned to the block, then there was not an option to actually view them before purchasing. And now in the biobanking space, and the viewing of whole slide images of these specimens is kind of a standard procedure. So if you use a biobank that doesn't do that, just find one that does, because then you can at least look at it and see what you're buying. But here they are going one step further, because they take the H&E images and predict other properties. So PathQC provides sample quality control through the direct quantification of the molecular integrity, RIN, and structural degradation, autolysis. It extracts morphological features from the slide using a recently developed digital pathology foundation model, UNI, which we talked about in one of our DigiPath Digests. I should have prepared the number of the episode so that you can immediately go to the episode. Maybe it's going to be on the screen later. But we did talk about this one when we talked about foundation models. And then we have a supervised model that learns to predict the RNA integrity number and autolysis score from these morphological features. And PathQC is trained and applied to the genotype tissue expression cohort, GTX. And that's a lot of postmortem samples, over 25,000 non-diseased postmortem samples across 29 tissues from 970 donors. And then they were paired with ground truth, RIN, and autolysis scores where available. So, excuse me. Then, they predicted an average Pearson correlation of 0.47 and for the RIN, and autolysis score 0.45. And I look at it and I'm like, is that good or not? Well, it's not that bad because the Pearson correlation goes from -1 to 1. So this is very much on the close to one side of this whole spectrum, right? So, hey, I take this every day of the week and twice on Sunday if this is available, versus nothing available, right? So I take this, and they have this available on GitHub. So if you are looking, is it something like you could run independently if a biobank you're using is not using it? Maybe you can suggest. But yeah, if you're buying specimen from biobanks, let's put it in a different way. If I was in charge of buying specimen from biobanks, I would want to see every single one of them, or have some kind of computerized AI system to let me know, okay, these are good, and flag them somehow so that I can look at the ones that are suspicious. Because there's different types of tissue going into biobanks, and this biomarker work relies on this type of tissue. And the last publication for today, before we go into the last one, let me just give you the QR code for the book. If you're just beginning the digital pathology journey, you need this book. And by this book, I mean Digital Pathology 101, all you need to know to start and continue your digital pathology journey. That's the QR code at the bottom of the screen right now. I'm just gonna hide the course. And I am super excited again to tell you that I did advance on the new version. And we are planning a launch of the new version, but everybody who has the old version, and the QR code is going to take you to a free download page for the PDF. There's an option to have an audiobook. If you don't want to read it, you can listen to me reading this to you. And there is a new version coming out with updated information, with stories from my podcast guest. So if you have this book, you're going to be on my mailing list. You're going to have access to everything I put out together. And the next conference that I'm going to is going to be US CAP. So if you're going, let me know in the chat as well. And then we can plan some kind of, maybe it's some kind of meeting space or something where we can just talk, because in the last year when I was going to conferences, I like go with my camera and go work with sponsors. And by the way, hopefully next week, the pre-Valentine episode, I'm going to reveal who's going to be the main sponsor for US CAP. So I'm definitely going to be at their booth, but it's still a secret. We're still working out the details. But in addition to that, or maybe I can work with them and figure out a time where we can meet, maybe you record something together, like digital pathology trailblazer conversation. I'm going to be letting you know what that's going to be. But if you want to be part of it, let me know that you're going to USCAP, and I will make sure that you know where I'm there and when we could meet. So the last paper, my trailblazers. Get the book if you don't have the book. And if you have a friend that doesn't have the book, send them the link once you scan the QR code. Okay, I'm going to hide the code for a second. This is a review, Machine Learning in Biomarker-Driven Precision Oncology, which basically is how we do oncology now. It's biomarker-driven precision oncology. And immunohistochemistry plays a crucial role in this precision oncology, precision medicine paradigm. So here, automated immunohistochemistry scoring and emerging direction in genitourinary cancer. So we are now talking specifically about GU cancers, and this is a group from Canada. Where is it? Immunohistochemistry is essential for diagnostic, prognostic, and predictive biomarker assessment in oncology. Manual interpretation, we've heard that like in 3 or 4 out of these abstracts already, is limited by subjectivity and inter-observer variability. But we have our tools that can help, machine learning and AI, and this allows algorithms to recognize pattern and learn from annotated data sets, or basically paired data sets. Now we have different ways of giving AI the ground truth. We have different modalities. And this automated quantification of biomarker expression on whole slide images is like the first application of digital pathology, first application of image analysis that actually made it into the diagnostic space. It used to be based on hard-coded features or handcrafted features. Now it's AI-based, but it has been there for quite a while. And this review evaluates the role of machine learning assisted IHC scoring in the transition from validated biomarker to discovery and emerging prognostic and predictive IHC biomarker for GU tumors. And these routinely used that you probably have seen and see all the time is ERPR, HER2, and mismatch repair, MMR, proteins, mismatch repair proteins, MMR, PDL1, Ki67, but they are also including androgen receptors, P10, cytokeratins, uroplakin-2, nectin-4, and immune checkpoint proteins. And then they also examine early evidence indicating associations between the machine learning derived metrics and clinical outcomes, which is what we want to have with these tests. Okay, are these tests related in any way to clinical outcomes? And can give us outcome information. And we also have limitations. And well, one of them is limited availability of training data sets, variability in staining protocols, and regulatory challenges. I don't know, this like blanket statement of regulatory challenges. I think there are like well-documented regulatory pathways that you have to go through, and they are challenging because regulators challenge you. So maybe that's what they mean, regulatory challenges. Yeah, if you want to go into the regulated space, regardless where you are, they're gonna make it difficult because they want to make sure it's working well and you can safely deploy it in patient care contexts. But overall, machine learning associated IHC scoring is a reproducible and evolving approach that may support biomarker discovery and enhance precision in geo-oncology. I remember, so that was for a research setting that I was doing it because I'm a veterinary pathologist, so I cannot do it in a diagnostic setting. I could for animals, but PDL1 is not necessarily a marker that is being used in animals. But I was doing this PDL1 scoring in a research setting, and then I was also developing an algorithm, a deep learning based algorithm to score it, right? And you've probably heard me like I sound like a broken record, but maybe somebody is here for the first time, so I was like, okay, so me visually was guesstimating the percentage of cells that were positive for PDL1 in the tumor, and then me, well, with the team, developing a tool that is quantification tool that was not based on like single cell, but was based on area of tumor, and then we were comparing this to each other, and the me guesstimating was the ground truth. So. And now we have better sources of ground truth, and we should look for better sources than pathologist guesstimation. And this is like a trigger, like when you, but that's how we were evaluating IHC and how we still are, and in many instances, because digitization, as much as we talk about it, and if you're here at 6 a.m., you basically probably love it as much as I do. It's not present everywhere, right? So lost my train of thought. Okay, so guesstimation. Yeah, so this is because the digitization in the lab is only maybe like 10, depending on the country, 15% of labs. Some countries even more, like in the Middle East, I think it's like 50% in some places. But it differs very much, and it's definitely not 100%. So these things that we're discussing are rare events in the diagnostic space, right? Even though I am a big proponent of them, the majority of IHC evaluation is going to be visual, which let's always put it in context. Like, better to have a visually interpreted IHC than not interpreted IHC. Better to have a computationally supported IHC interpretation than visual. Whatever you have, whatever is the best thing you have access to, do that and like provide the best care you can. Thank you so much for joining me. Thank you for scanning the code to the book. I'm gonna also include it in the show notes. If you're interested in going through the guidelines, I already heard some voices of yours to go through the guidelines together through the new publication from Poland, which I'm going to be super excited to be going through a publication from Poland. Let me know in the chat, even if you're watching the recording. Thank you so much for joining me. And I talk to you in the next episode.